Morning. Then we're starting 3.5. This is about rational functions. We will first understand what definition of rational functions are. We're going to take a look at what asymptotes means. There are two types of asymptotes, horizontal and vertical. We will learn about them. And we will also figure out domain of rational functions, x, y intercepts, and we will finally sketch those rational functions. Okay? So let's first understand the meaning of rational. Okay, when you look at the word rational, the first 5 letters means ratio. So you expect to see a ratio, a fraction, with a numerator, with the top and bottom. Okay? But what is special about on the top and bottom? You can't take anything on the top and bottom. Top or bottom should be either numbers or they should be polynomials. Okay? So numbers are polynomials as well. So what makes a rational function is first a ratio. You must have a denominator. This is the ratio. And the top should be a polynomial, like x cubed plus 3x squared plus something something. And then the bottom should be also another polynomial. Remember, just a single constant number like 3 is also a polynomial. Okay? They just don't have any x's. It's like 0x squared plus 0x plus 3. It's still a polynomial. You can make it look like a polynomial. Alright, what are some basic rational functions? 1 over x, for example. The top is just a number, bottom is just x. It's a rational function because both sides are polynomials. And when you try to factor the denominator, you can't because it's only x. So the factor form is equal to itself. When I talk about the domain, domain is again the set of numbers that can be used for x. What do I mean by that can be used for x? When you substitute those numbers in x, the function should not break down. It should not blow up. When do they blow up? For example, when you plug in 0 here, can you guys compute 1 over 0? No. This is undefined. So we should not include 0. So you either say like set builder notation. You need to take all the numbers x's, but you need to exclude. This means exclude. Do not take x to be 0. Or this is interval notation. You need to take everybody up to 0, skip 0. You see it's not bracket here, it's parentheses. We're skipping 0 and then continuing right after 0 to infinity. So this is the second part. So in questions you will be either asked to put your domain in set builder notation like the top. You just need to list the excluded values. Or you need to present your domain in interval notation. It can be a single interval, it can be a union of several intervals. The second example we have here is, you see, it's pretty crowded with terms. We factor the denominator. Look, they factored it to x minus 3, x plus 3, 4, and they found out there are two values, 3 over 2 and minus 4. They must be both avoided, because when I set 2x minus 3 into 0, add 3 to both sides and divide both sides by 2, we end up with 3 over 2. That's how they found this value. Okay, it's not just magically showed up. They set this into 0, set 0, set this guy 0, and you find minus 4 and 3 over 2. We exclude both. And how did they end up with this line? I'm sorry, these pieces of lines. 3 pieces of lines. Because of this, when you graph that domain, here is our real line. Remember, we need to exclude 3 house. This is 3 house, and we need to exclude -4. Here is -4. How many different pieces we have? We have now 3 pieces of line. First, second piece, and the last piece. Each interval here represents the corresponding pieces. Okay? Make sense? So first, find out the holes in the line or excluded values. Graph it if you wish like this, and read each piece from left to right and unite them. Okay? We've done this something similar in the past. And the last one is one of the most beautiful rational functions, bless you. And what's good about this is look at the denominator and try to factor it. Can you guys factor this? Ashley, I think you have an idea.
X plus 2, x minus 2.
Yeah, it feels like it's x plus 2, x minus 2. However, x plus 2, x minus 2 multiplies into x squared minus 4. It's square difference. The difference is minus, okay? When it's plus, these things cannot be separated. X squared plus 4 is prime. It cannot be factored. Trust me, you try x plus 2, it won't work. Nothing can make x squared plus 4. So we cannot factor it. Alright, we cannot factor it, but at least can you still set it into 0 and solve? Are there any values making this into 0? Maybe there are. Just subtract 4. And x squared equals minus 4. And I take square root of both sides, right? And we get x equals plus minus 2. Agree? Careful. Do you agree? Isn't it square root of 4 2? Right? No. This is incorrect because this is a negative 4. I wish it was positive. Right? Once it was positive, I could put plus minus 2, but this is undefined. We cannot take square root of negative numbers. That's why there are no numbers making this function sick, undefined. So we call the entire real line either this special letter R, this means all numbers, and this means also all numbers in interval notation. So that's the domain. That's why I call this function a beautiful rational function, because it has no holes or jumps. It continues from left to right with no interruption. Are we good so far? The rational means a ratio of 2 polynomials. That's all. Alright, it's time to learn more about them. So what really happens around these dangerous values? Again, let me go back to 1 over x and spot the dangerous value for 1 over x. What's the dangerous value for 1 over x? It makes it sick. This guy, bad guy. This is evil, right? 0. I'm wondering what's really happening around 0. Like you're really close to 0. Like 0.001 or negative 0.001. You're not really 0 at 0, but you're very close to the danger zone. It's like a mine. You step on it, you're dead, right? But when you're really close to that electric fence, kinda, what happens? So this is the danger. This is where the mine is, or electric fence is, like up and down going here. Your function can really go close to it, but it can never touch, like you're avoiding it. You're going nearby the borderline. This is the danger zone. What's happening to my function? My function goes up and down around that number. Do you see? This line is called, let me mark it again. This danger zone is called, what is it called? Do you know the name of this? Like electric fence is like lined up here, you're going really close but not touching it. It's called an asymptote. Since it's up and down running one, we call it a vertical asymptote. We're gonna name it in the next slide, but let's name it now. So every bad value in the domain is a possible candidate for an electric fence up and down or vertical asymptote. Okay? And your function go infinity. When I say up infinity, down negative infinity, it tends to go to either minus infinity or positive infinity from left or right. Sometimes both left and right goes up. So your function can go like this, both sides up, or sometimes both sides down for some other functions, okay? So you have the option, either you go up or down, but you never cross it. Crossing is not allowed because you get fried, okay? Got it? Alright, here's the demonstration why this is happening. Somebody took really close values to that number, like 0.01, and my function is growing huge. And you're really close to 0 from the negative side, negative 0.01, your function is huge value. Okay, and there is also some approaching going on the far right and left ends. This is far right. This is far left. What's going on the far left and far right? On the far left and far right, my function is acting like there is an electric fence, this time horizontal electric fence, and it's not touching it, it's avoiding it. Kinda, I shouldn't be crossing this green line, right? So when a horizontal approaching on the far and left, far right and left happens, we call it something. This line is called something. Guess what? There is also an approaching like this happening. What is it called? Anyone? Yeah, Chris?
Horizontal asymptote.
Yes, this is called horizontal asymptote this time because it's horizontal, going left to the right, right? Right? You see your function is not touching it on the far ends. Oh, can we touch it in the mid parts? Yes. Horizontal asymptotes can be crossed in the mid parts, but not the far ends. Far ends, you're going towards it, you're not really becoming overlapping it, but in the middle some functions can cross it. Not this one though. This is not crossing. Okay, let's take a look at our first homework question. It's just a test about what we just learned. There are 10 parts here. Wow. Alright, let's do the part 1 on this picture. What does this mean? Can anyone translate this into English? X arrow negative infinity. What does that mean?
Like the left side.
Yeah. Means negative infinity is negative huge numbers, and x's are happening to be negative huge numbers. So your negative huge numbers happen here, like right here. I'm sorry, x is here. So like -1, -2, -4, -1 million. So this means far left side. So the question here is on the far left side, far away on the left, where does the function values go? What do you see? Track these blue curves and check out the left end of the blue curve. Where do you go? Here is the left end. Do you go stabilize somewhere? Do you? Any idea? Does it look like your func curve is going towards something and it's not touching? It's almost that value though. What is that value? Is there, do you see any value? Chris?
They
Yeah, it's this value, right? Do you see that? Like your function values are here 2.7, negative 2.7, and then further down negative 2.8 and 2.9. Almost the far you go, you are lower and lower, but you're never touching -3. So you are becoming to -3, right? That's what it's asking. F of x values, these values are almost going to be -3. Part 1 is -3. Okay. What's the meaning of this now? -1, but you have a minus sign on the left. Let me copy it here so we can draw on it. There we go. Any ideas what this means? What is the meaning of this? X values getting really close to what the heck this minus sign on the top means? I have -1 here. Top corner minus. Have you ever seen something like this? No? Okay, this means you are on the left side of this number. What is that number? -1. So spot -1. Where is -1? Here is 0 origin, right? This is 0, 0. So -1 is this guy, correct? Alright? So you're on the left side of -1 means you're getting such values. You're getting these values, but you're closing towards -1. You're closing to -1, but you're sitting on the left side, very, very close to -1. Where does your function value go above these values or under these values? Just track. This one hits this guy, this one hits this guy, this one hits this guy. Does it feel like these values are moving somewhere? Where is it moving then? Okay, let me repeat. This means approach -1 from left side, approach to it. So you start a little bit off and I hit this value. I get closer and even closer and even closer. Where are these values marching towards? Where is the f of x values gonna stop somewhere? Is it gonna ever stop? No, the arrow means it's going to moon. So what is that ultimate value they're gonna go to? Yeah, it's infinity if it's all the way up, going up. Okay? Make sense? Didn't happen. Alright, part C. What do you see this time? The sign switched to plus. If the minus notates the left side of the number -1, what do you think the plus means? Right side. So you're going to approach from the right side this time. Pick some sample values to the right of -1. Here is -1. So I'm starting far off, getting closer, getting closer. I took 3 sample values. Let's track them. So where do I track them? I go up. Do I hit any value when I go up? No, blue curve is not there. So you need to go down. Let's go down and track those values. I hit this one first. Second, I hit that. Third, I hit this. Where are these values marching towards? From far to close. Negative infinity this time. Alright, we have, I see x is going to infinity. What does that mean? X is not going to a number to the right or left of number. It's just straight infinity. This means, translation, negative infinity means far left, positive infinity means far right. Where does your function approach on the far right? Just spot the far right end of this blue curve. Far right end is this. Are you going, is this arrow going towards a finite value, fixed value? I'm getting really close to it. What is it? Still -3. This line is -3. Actually, -3 is a horizontal asymptote, right? We call this a horizontal asymptote. All right. We have some other questions related to previous sections. I think we can do this on the screen. Is the graph increasing over at least one interval? Do you see any increasing part of this graph over at least one interval? Do you see increase? How do you measure increase? Just imagine you are walking on this blue curve from left to right. Do you ever feel you're climbing up on this curve from left to right? Yeah, when I walk here, look, I'm climbing and climbing up. So yes, I do feel an increase. Do you feel decrease though? Usually yes, right? Is it yes or no? Do you feel any decrease? Isn't this curve going down like this? You're sliding here, right? No, remember, you're always moving from left to right. Look, I'm going up, 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 and then I disappear, I'm out of screen, and then I pop up from the bottom again. I'm walking up, 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 up. This graph is always increasing all the time. No decrease. Left to right move all the time. No, it's never decreasing. Okay, over what intervals this graph is increasing? What intervals is this increasing? I said all the time it's increasing, right? So can I say from -infinity to infinity it's always increasing? Because it's always increasing, right? What do you think? What?
You have to exclude negative.
Right. Except this moment, you're out of screen at this moment. You don't know what happened to you, right? When you cross -1, there is electric fence there. You cannot cross it, so you're skipping that. So we need to exclude this. So take minus infinity to minus 1 and minus 1 to infinity, open parentheses around minus 1, correct? It's increasing over negative infinity to minus 1, union, and then you keep increasing after minus 1, not at minus 1, so okay. I lost power. There we go, we're back. Okay. I just typed it in, minus infinity to minus 1, union minus 1 to infinity. We're just taking a pit stop at minus 1. The domain in interval, oh, we're not even checking where it's decreasing because it's never, so they're not even asking. About the domain of this function. The set of all numbers you create blue lines is everywhere except one location you don't have any blue dot, right? Over that number you don't have any blue dot, which is minus 1. So I will actually copy this, or I can't. So you just need to type this in here. The same answer, 6 and 7 match. So I will skip this. The range, what is the range? Range is the set of all y values this function attains for each corresponding x value you entered. So the range happens on y-axis. All you need to do is smash this picture to y and see what region it's covered with blue dots. It looks like pretty much all numbers on y are covered, right? Then you smash this to y-axis, correct? So I'm gonna say from negative infinity to positive. Again, range is always red from bottom to top. Bottom is minus infinity, top is infinity. Do you agree? Why not? Except there is no point falling to this point, right? There is nothing to the left or right. You're really getting close towards it, but not really touching, nothing touching to minus 3 level. So we have to exclude minus 3. So when I read from bottom to top, I need to first cover negative infinity up to negative 3, take a pit stop at negative 3, and continue upward direction. Negative 3 to infinity later. Okay? From bottom to top, we need to read that. Okay? So I think you can type this in here. It's just time consuming. I'm skipping it. Alright, vertical asymptotes. Do you see a up and down running electric fence? Your curve is not allowed to touch, but it goes towards it. -1. This moment. -1, but we write it vertical asymptotes are typed in as x equals something. That number is -1. How about horizontal asymptote? Do you see your function has a horizontal electric fence? It's not crossing it on the far ends, but it's getting towards it. That number was -3. This. Again, you can cross it in the mid parts, but you're not anyways. But we're just looking the approaching sense on the left and right side. And that's y equals -3. Horizontal lines are always in the form of y equals something. Any questions? Okay. That was a kind of long, but useful exercise because it checked a lot of past information we know and current information about rational functions. Okay, we are going to now find out name and find out vertical asymptotes algebraically. Now, everybody here can find vertical asymptotes once I give you the graph, right? You just did it. You told me vertical asymptote here is x equal -1 because you literally see with your own eyes, right? What if I give you a problem like this, but you don't have a graph. How would you find it? So that's our topic next. How would you find vertical asymptotes directly from the equation, not from the graph? Again, the formal definition of vertical asymptotes is it's a vertical line. Your curve either goes towards it to the infinity, negative infinity from left, right, okay, sometimes from the same both top going up from both sides or both going down from both sides. All right, so there are 4 cases can happen: going up from left, going down from left, going up from right, going down from right. It's just one case. Once you see one case happening, one of them, one piece, then we call it vertical. You don't have to have both sides going to some infinities. All right, that's the picture. On the picture, you know what's going on, but how do you find it from the equation? Once you're given an equation like this or like that, how would you find vertical asymptotes? Okay, vertical asymptotes are the numbers x set into, or this in this time t is set into because our variable is t. How do I find that number? Those numbers are the ones that makes the denominator 0. Wait a minute, this is important. Once you factor the rational function, factor everything and cancel and reduce. So you determine these numbers after reduction. This is important. Most common mistakes happen because people rush into factor and set in each piece into 0 and see what makes it into 0. No, you need to first reduce it. Function should no longer have any cancellations left. Now we decide what numbers make the denominator 0. So first of all, can you factor this thing further? Is this factorable? 6 and t minus 3. Can you factor t minus 3? No, this is the simplest rational function ever. T minus 3 cannot be factored anymore. We call it prime. This thing is prime. So we are safe here. There is no more reduction. No reduction possible. Then we can go to the decision phase, decision making phase. Well, how do you decide? You need to decide what number makes t minus 3 0. For this, don't risk it, don't try to guess it, just set it into 0 and solve. What number is that? It's 3, right? That's it. So we have one vertical asymptote, and that number is 3. Good. Have I ever used the graph? No, all algebra. Going to the next. Alright, it's not that simple anymore, right? Look at what you have in the denominator, what you have on the numerator. What would you do on this question? Remember what to look at. We need to find and catch all x's that makes the denominator 0, right? Correct? So to find zeros of the denominator, they are called zeros by the way. To find zeros of the denominator, I believe we need to factor that denominator. Agree? So you guys need to work on this denominator and factor it. Does anyone know how to factor this thing? You will break 3x squared into 2 pieces. How would you break it?
3x minus 1 and x plus 5.
Hold on, let's first break this. 3x and x, right? Next, you're going to break 5 into 2 pieces. However, you're going to break it in such a way that when you multiply the outside terms and inside terms and add those, it needs to make 14x. Outside and inside terms must add to, multiplication of those must add to 14x. And you said, Courtney?
3x minus 1 and x plus
3x minus 1 and x plus 5. Is she right? Let's see. Minus 1 times 5, does it make minus 5? When I multiply 3x and 5, it's 15x. When I multiply minus 1 times x minus x, when you add them, do you get 14? Yeah. So we're done. We have two factors of this thing. Okay, next. What do you do next? Usually I look for cancellations. Can I cancel these and make this 3? No, we cannot cancel these, okay? That's actually good news, or I don't know, maybe bad news, because we need to reduce it. Again, we need to do cancellations so you have no more common factors among them. But this thing is not canceling, so we are safe. All we need to do is set each piece into 0 and find out those vertical asymptotes. This is gonna be 1/3 and this is gonna be minus 5. Agree? Just add both sides 1 and divide by 3. That's how I got it. What if these would cancel? Then we would have only one vertical asymptote. This wouldn't be a vertical if they could cancel. Alright, 1/3 minus 5. There are 2 then. 1/3. Alright, coming up next we have horizontal asymptotes finding procedure. Everybody can name horizontal asymptotes if you are given graphs like you did earlier. What was the horizontal asymptote here? Y equals minus 3, because I literally see with my own eyes. But what if you don't have no graph but the function equation on me? Just the equation. How would you find horizontal asymptote? Here is the procedure we're gonna use. It looks like a very complicated thing. What the heck this means, right? But it's kind of easy. Just read, take a moment and read. Try to make sense out of it. But I will explain afterwards. Alright, here is what this says. To be able to find out horizontal asymptotes, all you need to do is you need to find the biggest exponent of the top and biggest exponent of the bottom. They say find out m and n. What does n and m stand for? N is the largest exponent of the top, m is the largest exponent of the bottom. All you need to do is find m and n. So what is n in our question? Largest exponent of the numerator. This is numerator. What is the biggest exponent do you see? 2. What is m, which is the biggest exponent of the denominator? It's these guys again. It's 2 as well. Then what do we do with these numbers? Now you're gonna pick one of the 3 cases. Either n is greater than m, then there is no horizontal asymptote. If you find n to be, for example, 3, m to be 2, n is greater than m, then you will go ahead and say, oh, no horizontal asymptote. Part 2, if the bottom number is bigger than the top, like m is 5, n is 2, then we have y equals 0 as the horizontal asymptote. Y equals 0, that's it. And case 3 is the most interesting case. If you happen to have those two exponents the same, which is our case, right? Are they the same? So we have case 3 here. Case 3. What does it say? You need to find your horizontal asymptote. It exists, but you need to compute it as a ratio of two numbers. What are these numbers? How do you go search for them? What are these? A sub n, b sub m. Where do you go find them?
The coefficients.
They are the coefficients of the top and bottom leading terms only, not the everything else, just the leading term coefficients. So what is our horizontal asymptote then? Y equals -3. Okay? So we have one horizontal asymptote, and that is -3. What did I do? Oh, this is, I'm solving the wrong question. No, I'm not.
It just has two parts on that part. Gotta answer the other one.
Oh yeah, I didn't pick that up. Okay, what's the meaning of crossing the horizontal asymptote? You need to answer that one. Okay, here is what it means. Now, I detected -3 is the horizontal asymptote, right? So this is the situation happening here. Oh, I don't need that. This one. There is a curve here, but it goes towards y equal -3. Here is my y equal -3. This is your horizontal asymptote. And your curve goes towards it on the ends. End parts, okay? Like this. The question is, what happens in the middle part? Do I ever go and cross this several times maybe? I'm crossing it, can you find them? It's possible that you may cross it. How can I find these point or points? It can be one or more than one. Okay? That's the question we need to investigate on this part. Crosses or does not crosses? How can I find that without graphing it? I don't know the graph. You don't have the calculator to graph. From this equation, if you want to check two curves, there are actually two curves here. One of them is a line. This is line. This is the curve. If you want to check a curve and line crossing each other, what do you need to do? You just need to set their equations into each other. So what is the curve equation? That rational function? Plus 6x minus 4 over x squared plus 4. And what is the line equation? Horizontal line equation. This. All you need to do is set these equal and solve for if there are any x values showing up. One x value here, another x value there. If there are two crossings, you will get two x values. Okay? So let's do this. I'm going to put this -3 to this side. right here, and I'm going to solve it. Here we go. Okay, so take the equation of the curve, take the equation of the line, set them equal each other. Or how do you solve such a mess? What's the idea? What's the trick? This is a fraction. Set it into number.
Can you multiply it with the denominator?
Yeah. If you see anytime a denominator's equation, an equation with denominators, your first task should be to clear those denominators. So I recommend multiplying both sides with x squared plus 4 so that these guys can wipe off each other. We will have on it the top of the ratio, top of numerator on the left, and on this side, however, you need to really multiply this through and get minus 3x squared minus 12. What is next?
3x squared cancel.
Yeah, we need to bring x's together, so I'm going to move this to the left by adding 3x squared to the left. But wait a second, something great happens. Not only this side clears, but also that side clears. When this guy moves to the other side, it combines with this and it clears it. So you have only 6x minus 4 equals minus 12. And next, I need to get x's alone, and I have 6x equals minus 8, and x is 8/6, or this is equal to divide by 2 4/3, right? Negative 4/3. We found it. They cross each other, not twice though, once. It crosses once, and probably this side is going like, it crosses once and it goes like this. It gets closer to that line, like that. It never crosses again. That crossing location is at negative 4/3. It does cross it. And they want both coordinates. I just found the x value. I know the x coordinate is negative 4/3. How do I get the y value? I need help. I don't know the y coordinate of this thing. How do I find the y coordinate of this point right here?
I'm trying to see who crosses -3, so it'd be -3.
Yeah, this is a no-brainer because this point is also on this line, horizontal line, and it reads me -3 quickly. Or if you want to try the long way, plug in that minus 4/3 in here everywhere, waste several minutes on this, you will end up with the same answer, -3. Okay? But it's automatically, I know, since this is a common point between two curves, and this second one is y equal -3, it always reads me -3 on any point on the line. So I'm gonna go with minus 4/3 and -3 couple. Agree? Alright, finally it's over. Any questions? Are we good? Alright, moving on. It's just we're gonna practice more and more until the last question. And yeah, there is also a third type of horizontal asymptotes we are gonna find out here. And the last question is a very comprehensive question we are gonna take a look at tomorrow. Okay. Okay. Alright. Let's do this again. Horizontal asymptotes. I need to find N and M. Who can read me those? N is 3. M is 1. So which case are we going to use here? Which case? Yeah. 3 is more than 1. N is greater than M. Question is over. What is the verdict? What's the conclusion? No horizontal asymptote. That was easy, right? What's the, I mean, if there is no horizontal asymptote, can your function cross this horizontal asymptote if it's absent? No. Part P is not applicable. This was a 10-second question. You just read the numbers and compare. Alright. I believe we're gonna do something on this one. You do this one and tell me the horizontal asymptote, if it exists. Any results? Anyone? Any results? Y equals 0. Okay, let's verify. What's the degree of the top, or what's the biggest exponent? There is no x, then it's 0. No x, only constant, then it's 0. M is, so this is the case, n is less than m. Top is less than bottom. If top is less than bottom, it's case 2, and line y equals 0 is the horizontal asymptote. Y equals 0, that's it. Case 2, y equals 0. Alright, now, can you cross this? Do you think it's gonna cross it? All you need to do in part B is take that equation and set it into 0, the right side of this thing. And how do I solve this? Remember, our first target is denominators. Get rid of them. So how can I get rid of this denominator? Yeah, whatever you see here, put it to the both sides and multiply. Right? Oh, we need to multiply 9 by this now, right? Correct? No. No, it's just you need to cross these off. Because that's why we did it. We want to clear the denominator, right? So 9 on the left. What is 0 times something? 0. 0 times x squared, 6x and 9 makes 0. Wow, this is a great day because you have proven something impossible. You just proven 9 equals 0. Can it be possible? No. This is impossible means no solution, no crossings. Okay? That's it. There is 1, that's y equals 0, but they don't cross, right? Alright, last question of today. It says identify the asymptotes, but a good surprise is, or bad surprise, there is one more type of asymptotes we haven't explored yet. It's called slant. The word is slant. Means it's neither horizontal nor vertical. It's going with a slope like this. Your curves can sometimes get really close to a linear equation, a line. But that line is neither horizontal or vertical. It's a slant line. If such a case happens, you need to identify and find it and call it slant asymptotes. But good news is, it rarely happens. Rarely. But when? How do I detect? When I take a look at a question, how do I know, oh, there is a slant asymptote here in 2 seconds? I can identify slant asymptote. I can decide there is a slant asymptote or not in 2 seconds. What is the test? Test is degree of the numerator should be exactly 1 greater than the degree of the denominator. Check out this. What is the degree of this numerator? Degree of the denominator. What is the difference? Exactly 1 more than the bottom, right? Top is 1 more than the bottom, correct? And this one, yes, it has 1 slant asymptote. Okay, so I do know it has at least 1 slant asymptote. I also need to find vertical, horizontal ones, but you already know how to do that. So, does it have a vertical asymptote? Does it? Vertical asymptotes happen on the locations where denominator becomes 0. Is there a value of x that makes the denominator 0? Is there? What is that value? Does this thing ever happen to be 0? Yeah. When? But you may object and say, wait a minute, aren't we supposed to factor everything and cancel first, right? Well, I tried that. This top equation is not factorable. I couldn't find easy factors. I couldn't find x minus 6 here. I wish there was so I could cancel it and there would be no vertical asymptote. But no, this top equation does not factor. Can you factor it? Top one? Can you factor this? No. I mean, you can try minus 2x and 1, x and 7, but it's not gonna work. You can try 7 here and minus 1. Minus 2x squared minus 2x plus 7 is not meeting the middle one. And you can actually even do quadratic formula, and you will end up with some factors with square roots, so it will never cancel with the denominator because the denominator is x minus 6. In other words, 6 is not showing up on the factors. So I'm not even doing the factorization of quadratic formula, okay, with quadratic formula. So it cannot be factored. I know this is a vertical asymptote. It does have a vertical asymptote, okay? So we can go and choose this one. There is one vertical asymptote. How about horizontal asymptote? Do you have any? What is the test? You need to call what M and N are. N is, anyone? 2. M is, N is greater than M. What is the verdict? If top is more than bottom? None. Okay? In case you forgot it. Here. Top more than bottom? No horizontal asymptote. Okay? And let's go ahead and call none here. Alright, vertical asymptote they're gonna ask. It's minus 6 already, we know. Slant asymptote. How do I really find it? I know it exists. But how do I find it? It says right here. You need to do long division, or you need to do, if it's convenient for synthetic, do synthetic division. All you need to do is to find the result quotient and set it into y. That's it. So is this question convenient for synthetic division? Can you do synthetic division for this one? No, Maddie? You can do long division. Again, you can perfectly do long division and put minus 2x squared minus 3x plus 7 here, and x plus 6 here. This part goes here, right? And then you can do long division, but I don't want to consume time. Can I do synthetic division?
Yeah.
Yes, because this is linear. It's first degree and then just add number. We can do synthetic one. So let's do synthetic. I put here divisor here. I mean, just take the number part. It's 6, right? It's negative 6. Remember, we take the opposite of this number here. And I take the numbers in front, these 3 numbers, right on the top. Minus 2, minus 3, and 7. Okay? Hence, we first bring this down, multiply by minus 6 and put it underneath, which is 12. It's a 9. Multiply by 9. We get minus 54. That's minus 47. We don't care about this anymore. Anyway, this is remainder. They don't want the remainder, they want the quotient. Where is the quotient then? So again, we don't care this one. This is the quotient. But you just need to write it as y equals an x expression. How? How do I use minus 2 and 9? You put 9 first, plus 9. And you put minus 2 here as how? That's it, minus 2 plus 9?
X.
Minus 2x plus 9. Okay? Okay? That's your slant asymptote. When you graph that minus 2x plus 9 and you graph this function, they will almost go side by side towards the far right and left ends. Alright. Now, number 8 is the main mother function of this section, problem of this section. It's very comprehensive, very, very summary type question. It checks everything you know so far about rational functions, what you learn in one question. Okay? And we also learn graphing techniques. So it's gonna take a while, so we're not gonna start it today. We're gonna do it tomorrow. It's basically following 8 steps. In each step, we are repeating what we've done today and in the past. So it's kind of good review. Okay? And that will be all. This will be so this is the cutoff. 3.5 is the end of exam 1 contents. Okay, so whatever we start tomorrow, I'm not gonna put it in the exam afterwards. This